This video describes my build of an incredibly useful variable AC-DC power supply. The specs turned out quite impressive. This PSU can supply isolated 0 to 120 volts or non-isolated 0 to 240 volts AC. So I can use it as a step up or step down kind of supply. And kind of importantly, 350 volt DC. You can switch earth in or out for true isolation, and also which switch on the front panel is live. That means in the US, I think live is on the left with reference to earth, and on in international is on the right. Can do up to 2 to 3 amps maximum. Built it out of 5 millimeter plywood, which I think I made a mistake, but it is what it is. Uh, So on 120 volts setting, you can go smoothly from around 0 volts to 120 volts. The AC power meter does show a few seconds lag, which I had not expected, but it otherwise quite accurate. I just kind of have to keep in mind that there might be a lag when I set it up in the future. So then when I move to the 120 volt setting, sorry, the 140 to 240 volt setting, you can get from 20 to 240 volts with no issues. So here again, you can see on the left, the switch is on the 240, and I'm jacking up the voltage to beyond like 200, and hopefully right there to 260 to 70 volts almost. Quite impressive. And then a quick check on the DC setting. When I switch to the DC setting, which is the switch on the right of the instrument, and I've reset it to 120 volts, I get approximately 200 volts on the 120 volt AC setting, and around 350 volts, which I've not shown on the. And you can see stupidly, I've kept it on the AC setting on my multimeter. So no AC leaks through, which is kind of good. Now on the DC setting, you can see it kind of gets to like at the 240 volts DC setting. I can jack it up to more than the meter setting. So it will go up to almost like 350 volts. So how did I construct it? For construction, I first had to figure out what I had, what parts I had, then designed a circuit around that. I also had to modify this neat little AC power meter read from 0 volts instead of its standard minimum of around 80 volts. I have a separate YouTube, which I think I posted just a while back. So, and then I also had to make an AC DC converter and kind of convert a couple of existing USB power supplies to feed the AC meter and the DC meter. The enclosure I wanted was limited by a size of 6 inches. It's just that a rule I have most of my DIY projects are, units of 3, 6 inches or so. And then, of course, assemble the system and then do the testing. So the most important parts are the transformers. I did have a non-working around 2 to 3 ampere variable transformer showed on the right from a dead electrophoresis power supply that I had to repair. An interesting transformer on the left from an Eppendorf centrifuge, which was used to select 120 or 240 volts. It's showing 3 leads, but the lead on the right is actually has 2 wires inside. So there are 2 separate coils. I could use it for isolation. And the rest of the things were like an AC plug, which I think from some remaining voltage converter. I did buy the AC power meter. I had banana plugs from an old PSU that I essentially retired. I bought a new 500 volt DC voltmeter from I think from AliExpress, and the switches were a bunch of switches that I got with stuff for something else. So I had most of the parts. So then I designed a circuit. Sorry, before I designed the circuit, I wanted to show a quick thing on why the variable transformer was not working. So the one of the wire had broken either I think during maybe before I acquired that electrophoresis power supply, or when I was trying to kind of disassemble it. So I saw it. It was pretty easy to repair. I put a piece of aluminum plate below so it wouldn't damage the varnish on the other wires. Kind of tape things so the wires are relatively close, and then soldered it. The soldering is actually better than what it looks in the photo. and then tested it with the ohm meter and final AC. So I got a fully working variable transformer, and you can see it's around two-ish amps. So I think when I stressed it with heat or so, it went to around 2.5 amps. So worked good. So that gave me kind of the most important component for my AC power supply. The circuit has a bit of complicated wiring, but basically it's four sections. The first section, hold on, let me get the, is right here. This first section essentially converts the incoming AC. I had an ISC AC socket with with a fuse built in. I put a lit power switch. It has an inbuilt neon and resistor. So this converts the 120 fixed to variable 0 to 120 volts, and that was the repaired variable transformer. Then the second part, which is kind of shown here, is it essentially it switches the 120 to either one keeps it at 120 or goes to 240, and this is by putting the isolation transformer, the two coils in series or in parallel, and the switch kind of does that. Then the last section was a DC converter. Essentially, it's a bridge rectifier with a diode and a resistor across it, which converts the variable AC either at the 120 volt setting or the 240 volt setting into a DC output. And the meters are connected, the DC meter is connected across the switch, which converts AC to DC. And the power meter is connected to the output of this variable transformer section. So yeah, I mean there's a bit of wiring, but it's essentially quite simple thing. So I'll focus on maybe the most complex part of this bill, which was the 120 to 240 volt AC, and it took me a while to figure that out. So I've kind of zoomed in here. So what happens here is the live comes in to the top of the variable transformer, and the neutral is to the bottom, and this is the wiper arm of the variable transformer. The switch essentially either feeds only the top coil of the isolation transformer, so it feeds the live and the neutral to it in this position on the left. So the switch will short here, and essentially this the live will be fed, from the variable, and then the neutral is connected directly to the secondary output. So this output on the 120 volt setting essentially goes in, and then it connects to the live. So this is isolated from the top coil. You can see there's no connection between this set of wires and this set of wires on the 120 volt setting. On the 240 volt, the slider shorts the right two terminals. On the 240 volt, the output of the switch, the live, is now connected to the input. So I've lost isolation. So these two guys are shorted together. So I get live directly here, and this end of the coil of the transformer coil is then connected to this. It's in series now. So this connects to the bottom here, and this is always connected to the neutral. So I lose isolation, but I essentially get a step up from 120 to 240 volts because the coils are in series. Hopefully it made sense, but it took me a while to kind of make sure I got it right in there. So now first thing I did was I drew a layout in Inkscape of what my the front panel would look like, and I had the approximate measurements. There were a few errors which I discovered later, and then just laser cut it on the laser etched and laser cut the panel. So this is the resultant. I had to do some size corrections, with a bit of filing. You can see here and a bit of damage here. So I did a test fit, and my holes were a bit things. I also changed some of the connections. So initially I had a earth yes no switch here, and I changed that to a live switch, which you'll see later. This is the AC DC position. This would be the 121 port, and I had a neon here to show that the earth is switched in or out. So I just used that spot for a simple switch to switch the earth. So I kind of could get this here. This is where the variable transformer connects, and this is where the banana sockets connect there. So the back panel was pretty simple, just the IEC socket and a hole for the for the isolation transformer, which is kind of shown here attached. So I started stuffing, the components, the main components in, the three switches which I had acquired, I think, again, like I said, from some auction package somewhere. Uh, these were pretty robust. I mostly use the two parts of the three ways. I did not use the center except for the AC DC. So this is the power switch. I also put a fuse on the output before it's fed here. This is the AC power meter. Here I'm not showing the modification. This is before I modified it, but post modification, there were DC leads that I connect. So I disconnected from the AC that feeds the power to a DC input. The three switches, the repaired variable transformer. This is the 500 volt DC voltmeter, the banana sockets, and the output for the AC plug. This is another view of what it looks like. The having this kind of transformer saves a lot of space. I was glad I had harvested this from that non-working centrifuge, uh, and again, like I said, I regret using cheap plywood to make the container. So this is 5 thick plywood, which I had cut on a bandsaw, I think, except for the front panel, and then I did the cutting and etching. Uh, I had to do a lot of drawings of how to wire just to make sure I kept it straight. I won't go into details. It was pretty tedious and painful. So I've just toned down the color a bit as you can see it. So for example, this is in a way the live switch output. This is neutral. So the neutral connects to one of the variable transformers, the bottom part in my initial circuit diagram. The live connects to the top part, which is wrong here. I just discovered it's wrong. Anyway, so ignoring some of the things, but I had lots of these diagrams to figure out what I was doing, and I only see I made a mistake here, but when wiring it, I think it was correct. So, and a warning, right? You are working with pretty high voltages here and with mains voltage. So getting this right and checking it with a ohm meter is incredibly essential. I didn't capture videos of it because it was kind of messing up with my concentration there. So just one more. This is the output side. So essentially, this is earth, the neutral, and live. In US, it's switched around. So this is the switch, which switches live from left to right or right to left, depending whether you're looking in the front or not. So the output, so the AC input is here for the AC meter, and the output is on the external terminals. So output goes through a fuse, then that fuse go to the switch, which switches the position of live, and then that is fed to the output here. So this was simpler. Like I said, the other one was a bit more complicated in there. Okay. So I finished kind of the main thing. I also had to make some AC DC converters, which is pretty simple. So I just essentially wired. I didn't have a rectifier for the specs I needed. I needed high voltages around 3 to 4 amps. I didn't have in my parts bin, but I had individual diodes. So I took this diodes, which are spec'd at 1 kilovolt, 3 amperes, and essentially just soldered them together and created a little bridge rectifier, kind of shown here. And then I put a 10 microfarad 400 volt capacitor across this rectifier and directly connected it to the AC DC switch. Sorry, it's kind of hard to see, but the AC input comes to these wires here. Uh, and the AC input is before, the kind of from the output of the AC power meter. So whatever variable voltage, AC voltage you have selected, that variable AC from 0 to 240 volts will be input to this rectifier, and then that gets converted to DC. In the beginning, I did not have a bleed resistor across here, and I saw the voltage kind of stuck on the capacitor for a long time. So I had to, after the fact, kind of make a bleed resistor, and I did that by connecting half watt resistors, 90k ohm, I think five of these in series. So, the voltage burden would be spread across those five resistors, and then soldered that across the switch terminals across the capacitor. So that would help bleed it. So this had around 450k ohms. Each resistor was zero point 0.5 volts. So I think the total resistance to high voltage was around 1 kV or so. So this kind of kept it safe. And it's hard to see here, but this is the one. It's kind of in a U-shaped tube. So it's soldered to the capacitor one end, and then the other end is soldered here. So this was the kind of resistor, which was important. Otherwise, my DC meter was just showing voltage when there was no load connected. The DC meters, I thought I could feed it with one DC voltage, right? The AC power meter and a separate DC power meter. But the grounds are separate because if it's isolated, there's a left and a right ground. So they kind of messed up the readout when I was trying to feed them from a single supply. So I had to feed them from two individual supplies. The first one was one of those old Apple tiny cubes. So I opened it up, and surprisingly, this was one of the original Apple cubes, not one of those fake. Either would have worked. I used the Dremel, so you can see the white stuff all around, and then gently pulled out the two circuit boards and the unit. It's quite nice. They have even a filter for transient suppression, etc., built in. So beautifully engineered. There's quite a bit of YouTubes around this. I won't kind of go into it. So I looked at the circuit and I could see, so this is the USB output on the top, the one that would be fed. And this is one of the 330 microfarad capacitor. The negative connects, I think, was short, is in short or intentional short with the negative of the USB. There's another capacitor here and there is a coil here. So this capacitor and coil are kind of connected together and they were to the positive of the thing. And I did find a circuit online, which I'll kind of show you here. So the circuit is, so this was that 330 microfarad capacitor. This one here, I've rotated it around. The coil is here. So sorry, slightly damaged by me, but still work. And the 100 microfarad capacitor is this yellow one here. So I connected wires to this point here, to this location here, and another wire to the base to this the 330 microfarad capacitor. Easy to access. I had two wires here because I was hoping I could feed both meters from a single supply, and like I said, it didn't work. So basically one extra wire there. And then this just kind of zooms in. So I kind of glued the USB supply. I used another standard 5 volt USB supply, which was for the this one I used for the high voltage DC meter, and this one I fed into the AC power meter. And you can see I had two leads kind of going here. I think might be a bit more clear. So this was the modification. I essentially opened up the AC circuit which fed this power supply, the internal power converter, and just put an external DC which came from this USB supply. So uh, and then the high voltage DC power supply, the 0 to 500 volt meter, was put across these two terminals. These are the outputs which connect. You can see this one connects to the positive, and then the negative connects through the switch to this DC converter, which is on the bottom here. So the meter was connected to there. It was kind of irritating having this DC meter on even when I was not doing DC. So when the switch was in the AC position, the DC meter was on and it's kind of bright. So what I did was the 5 volt power supply, I switched that through this extra switch terminals I had here. I hadn't used them, so there was a second row. So I used that as a power switch for the DC power meter. So when the switch is on the AC setting, the DC meter is off. When it's on the DC setting, the DC meter is on. So that kind of made it a bit more attractive too. And it just shows the kind of bird's nest packaging or wiring, I should say. So here is the 5 volt meter which feeds the AC power meter. Here is that other 5 volt meter which kind of hidden here, but feeds that DC meter which is somehow stuck here. So and then of course, once it was assembled, I did the testing ohm meter test first, and then voltages here. And here I trying to see what did I do here. I forgot. Yeah, I'm testing the earth connected or not, and you can see here the earth switch is off, and there is no voltage drop from the AC output to earth. So this is independent of earth. And you can see that these AC DC switches on the left, so the DC meter is off. I did some more improvements later on, so this video I shot earlier. This is a button that controls the meter for resetting energy and stuff like that, or for turning it off. So worked okay. So I put this is just one video of the mini test I did. I put a 40-watt bulb onto the DC output, and you can see here at around 2 volts AC input, this DC converter makes it to around 4.7. Sorry about the glare. I did put a filter on later, so which kind of improves it. Uh, and you can see as I increase it, the bulb lights up on the left. I didn't want to go too high, so I stopped at around 80 to 100 volts. I didn't blow the bulb out. Uh, so this was it. It's turning out to be pretty useful. I developed it essentially for controlling this new high power LEDs, which have the power built in. So you put in AC and the LED comes on, the high power LEDs come on. So this was the main purpose for controlling it. Thanks for watching and have a nice day.